When the sun isn't shining and the wind isn't blowing, we can't produce electricity. Ready? If you've been in the news recently, you might have heard of this little thing we like to call climate change.
Climate.
How dare you!
It's everywhere. We see it in the streets where people are protesting about our irreversible damage to the planet. We see it in the constant news stream of icebergs falling, of scientists saying that we are going to destroy our planet and that it's the apocalypse. And on the other side, we have people saying it's fake news. Climate change isn't real. You all are getting fooled by Greta. I think that it's not the apocalypse. I think climate change can be solved. But I also think that it shouldn't be denied. I do think that oil is important. We should keep burning oil so that it supplies our energy needs. But as we do that, we cannot deny that GHG emissions are going up, which means that the planet is warming, which means that we can create irreversible damage to our Earth by going over 1.5 or 2 degree deltas. What does that do for us? Well, we have about 30 years to completely decarbonize our entire world. Hydrocarbons and liquid hydrocarbons have been the blood of our economy, the blood of our world, for years. Liquid hydrocarbons fuel literally everything we do, from the electricity we produce, to the transportation system that we use, to the plastics and the chemicals that we make. Now we need to completely decarbonize so that we don't hurt our planet irreversibly. And a lot of people will say it's impossible. A lot of people will say it cannot be solved. And this episode is going to be talking about what are the solutions out there for climate change and what can we actually do to actually make a difference. This series is called How to Solve Climate Change because I took it on to myself to look into the research behind it and come up with solutions for some of climate change's biggest problems. There's a lot we can do as a society to completely decarbonize our economy. So let's get into it. When it comes to climate change, there's no better book to start with than How to Avoid a Climate Disaster by Bill Gates. We finished it. In Bill Gates' book, he basically defines electricity with around 27% of all global emissions. Transportation, cars, trucks, all of that is 16%. Agriculture, how we produce our food, is 21%. Buildings and creating cement and all of the industrial things that we do to kind of run our cities are 7%. Manufacturing with 30% of all global emissions. So after I read this, I said, okay, what is the biggest problem that if we solved would make all of the other problems easier? Electricity production and manufacturing are more than 50% of our problem. But what you might realize is that manufacturing and electricity go together. And so if we solve the electricity problem, then we can solve a lot more problems than just 26% of all global emissions. Now that we've proven that electricity should be our main focus, what do we do with that information? Well, there's a lot of different ways of producing electricity, so let's go through them one by one. Now, there are a lot of ways of producing electricity, but the main ones are natural gas, coal, nuclear fusion, nuclear fission, renewables such as wind and solar, and then you have also things like dams, geothermal, and biomass. So first we have coal and natural gas, and of course those produce GHG emissions, and they're all around kind of the thing we're trying to avoid, the thing we're trying to replace. So let's get them out of this corner. Now you have nuclear fission. Nuclear fission is basically splitting atoms in two. You produce a lot of energy from that and you produce electricity from it. We've had nuclear fission reactors since the 1950s. But what really happened? Well, a lot of people, for better or for worse, are really scared of nuclear fission right now. things like Chernobyl and Fukushima, and then you also have things like Nagasaki and Hiroshima with the bombs. And so nuclear doesn't really have a good rep right now, and a lot of countries are actually moving away from nuclear, shutting down their nuclear power plants, and going to things like renewables, or even worse, coal or natural gas. Is nuclear really the way out? Well, for now, right now, the PR is really bad. But if the PR wasn't, I would say nuclear is amazing if we get our shit together. Nuclear can produce a ton of electricity. You can put a lot of nuclear power plants everywhere for a relatively cheap cost, and it produces electricity 24/7. But the problem is that nuclear right now just has the bad reputation, and a lot of places in third world or second world countries don't actually have the resources to build their own nuclear fission plants. So maybe for first world countries, it might be a good way out, but for third world and second world countries, it might not actually be the best way to go, since, third world countries don't have the resources to build these giant nuclear reactors that split these atoms in two. Now there's fusion, which doesn't have the negative byproducts of nuclear waste and all of that stuff, and it also has a really good reputation. It's basically fusing two atoms to replicate what's happening in the sun. The problem with that is the technology has been 50 years away for 50 years. That's the running joke in fusion, and even from talking to experts, they think that maybe fusion reactors will be on the grid maybe 15 or 20 years at best. We can't be waiting on a solution 20 years away. So let's go with the facts right now. Fusion and fission aren't the best solutions to our problem. What about geothermal? Well, geothermal is actually a really good way of electricity production, but the thing is that it's relatively costly and it's also geographically bound. We don't want things to be geographically bound. This is a main thing you'll see in a lot of the things I talk about. Geographically bound things are bad because then you're just relying on your geography, and not everyone has the geography that geothermal has. You need to harvest the heat from the earth, and you need surface heat, and not every place has a huge amount of surface heat. The same for hydroelectric dams, for example. In Quebec, where I live, Montreal, basically 96% of our electricity is produced by hydroelectric dams. The problem is that not everyone has access to these huge dams and rivers and things like that, and so you're kind of relying on hydroelectric to save you, but not everyone has those type of resources. Geothermal and hydroelectric are out. Okay, so what about biomass? Now, biomass is a really interesting process. Essentially, you're taking biomass, and in certain processes, you turn that into oil, and then you combust that oil. It's a net zero way of doing things because biomass is already taking carbon out of the air, so then you're just kind of recycling that carbon to produce electricity. The thing about biomass that is a bit bad is that it can only work for very micro solutions. And the reason why that is because, well, we don't have enough biomass to supply the world's energy needs. You want to take the food we're already eating and you want to produce electricity with that, you're going to cut our food production in half. Even if you take things like food waste, which are already kind of out in the open, like there's not enough food waste to supply the whole world's energy needs. And also, biomass centers aren't really the cheapest solution out there. So what's left? Well, renewables. Renewables such as wind and solar. Solar, right now, is the cheapest form of energy on the planet. I will get into some of the costs later on in this series, but for now, if you take a natural gas plant and you build it from the whole way up, then the natural gases plant cost is going to be higher than the solar plant that you build up. Now, it's not as simple as that, but for now, let's just say that solar is the cheapest form of energy. And wind is very close to that. They are renewable sources of producing electricity, so you never have to worry about running out of oil or running out of biomass. They are renewable sources that work all the time because the sun is always going to be shining onto the earth. So if renewables are the cheapest form of energy on planet Earth, why isn't everyone converting to renewable energy? Well, this is where we get into the interesting part. The problem is not actually how we produce our electricity. We already have the resources to produce solar panels en masse, to produce wind turbines en masse for very cheap cost. The problem is that renewables don't work 24/7. And this is what we call intermittency. Essentially, when the sun isn't shining and the wind isn't blowing, you can't produce electricity. What we need to do is store the excess electricity from solar during the day and redistribute that to the grid during the night. That is what we call energy storage, and it's currently, I think, the most important problem in all of climate change. If we can store the excess electricity from renewables during peak hours of production for a very cheap cost that is cost competitive with natural gas, then we can essentially power the whole world on renewables. So let's go into energy storage systems and what I've been thinking about recently with ranking them. Essentially, what me and my partner decided a few weeks ago was that energy storage is probably the most important problem in climate change. And so what we were thinking was, are there any papers out there that really do a deep dive on all of energy storage and rank different energy storage systems based on their parameters? And what we realized is no, there's not an industry standard paper that basically ranks different energy storage systems and figures out which one is the best to solve the solar panel energy intermittency problem. In this series, we're going to be doing a deep dive on how we are building this paper based on our parameters and what we've been doing. I hope you enjoy because this is going to be a wild ride. I'll see you next episode.